Hi there, my name is Rory Brown. I'm a PhD student here at the University of Manchester. I'm studying graphene, how it interacts with other materials, and what kind of things we expect to see in graphene-based devices. So you might have already heard about graphene. It's been in the news quite a lot. It was discovered in 2004, won the Nobel Prize in 2010, and everyone hopes that it's going to change the world. Now, I brought some graphene along with me. It doesn't really look like there's anything there, but if you want to take a closer look, you can actually see what looks like a dark circle on the plastic. And there's your graphene. So before we go on to graphene, I'm going to have to talk about something a little bit more familiar, which is graphite, the kind of material that you find in your pencils. You might already know that graphite is the naturally available form of carbon, kind of like diamond. So in graphite, the carbon atoms are arranged in layered sheets, and each sheet has this honeycomb lattice structure where you have hexagons of carbon atoms. And these carbon atoms are strongly bonded to three other carbons by covalent bonding, leaving one free electron out of the sheet. Now the covalent bonds are very strong, which means that the sheets are very hard to break apart. But the electrostatic interactions between sheets are very weak, which means they can freely slide around on top of each other, which is why graphite feels sort of waxy, and is actually how pencils work. So when we write with the graphite in our pencils, we actually leave some of these layers behind on the sheet. So in our graphite structure, the graphene layers work kind of like our stacks of paper. Each layer is free to slide over one another, but is bonded so strong that you can't pull it apart or force it to break. So the bonds between these graphene layers in graphite are actually so weak that you can reach in with some Scotch tape and then just pull them apart by hand. And that's actually what they did whenever they won the 2010 Nobel Prize. They took graphene flex like this, put some sellotape on it, and then started pulling all the pieces apart. So whenever we make graphene, we take our sellotape, put it on our graphite, and lay it onto another material, silicon dioxide, the purple background that we see here. And what we're left with is some dark chunks of graphite that we find that we're not interested in, and the lighter layers here are the graphene that we are interested in. So here we see the light layers, which is the graphene that we're interested in, and some of the slightly darker layers will be where graphene has folded over on itself or otherwise formed a bilayer, which is two layers of graphene, one on top of each other. The slightly darker layers may be 2 or 3 layers, which we'll either call bilayer graphene, trilayer graphene, or depending on who you ask, graphite. So that's what graphene is, and it has a whole load of amazing properties to go along with it. So as well as being the thinnest material ever discovered, at 1 atom thick, or about 10 to 100,000 times thinner than a human hair, it's also one of the best heat conductors that we've ever found, and it's one of the best electrical conductors that we've ever found. We've already seen that it's nearly transparent. It only absorbs 3% of all the light that is incident on it, but it's also, despite being 1 atom thick, stronger than diamond and about 200 times stronger than steel. So as well as using graphene for its mechanical properties, we can also use it in technology, taking advantage of its electrical properties. And we're starting to reach the limits of what we can actually do with silicon-based devices. Graphene might be the next big thing to replace silicon, given that, in theory, we can do everything better and at a smaller scale using carbon devices. So one of the advantages of using graphene is that carbon is one of the most abundant elements in the world, and we don't really need much of it to make these graphene-based devices. If you had a 10-gram sample of carbon, or about a teaspoon's worth amount, you could actually cover an area the size of a football pitch completely with graphene. We can take advantage of the fact that we've discovered a whole family of other atomically thin materials based on other elements and combine them with graphene to make devices that have never been possible before. So we can now make devices that are only a few atoms thick but have incredibly specific properties. And we can use these to make technologies that we've never been able to make before. So some examples of these technologies that we've not been able to make before would include everything from touchscreens to flexible phones. So if we could, for example, make a touchscreen or microchip out of it, and these other sandwich materials, we could put it in our phone and have a phone that we can roll up, or a phone that we can fold out to get a bigger screen. The carbon atoms in graphene can also easily bond to other molecules that may allow them to act like a solar cell, for example. And we already know that graphene is flexible and transparent, so you can make a solar cell that you can put on your window. Graphene can also be used in batteries, and the idea is that these batteries can actually discharge their electric current in a matter of seconds or minutes. So you could have a plug into your window that charges your phone in 2 minutes. We've also found that graphene's structure is perfectly suited to filter water. It allows small molecules such as water to go through while blocking out any impurities, giving clean water through a little filter, maybe on a straw. Graphene also has uses in medicine. So you can make a capsule out of graphene that encloses a drug or something that you want to deliver to a specific part of the body. And if you add a chemical on top of one of the carbon atoms, it can act as a zip of some sort. So the molecule unzips the graphene capsule and releases the drug wherever it needs to go. So hopefully through this video, I've been able to tell you all a little bit about what graphene is, what it does, why everyone's so excited about it, and what we're hoping it can be used for in the future.